Canola School on RealAgriculture.com is brought to you by Alberta Canola Producers Commission, Sask Canola, and Manitoba Canola Growers.
Kelvin Hepner with Real Agriculture at the Canola Discovery Forum here in Saskatoon, and we are joined now by Dr. Brian McConkey with Agriculture and Agri-Food Canada based in Swift Current. And Brian, today the title of your presentation, Why Canola is Cooler Than Cereals. So were you pandering to the audience, or what was the justification behind it?
I was looking at it from a cooler perspective from the point of view of global warming or climate change. So, and in that regard, canola is very different than every other crop that we grow commonly, and that is it produces a lot of residue for every seed that's produced. It has not only produces more above ground residue per unit of seed, so its harvest index is relatively low, or the proportion of the above ground that goes into grain is relatively low compared to cereal crops. But also it has a much larger root system as well. So again, in proportion to the seed yield, it produces much more root biomass and puts that into the soil than a comparable cereal crop grown under the same conditions.
So that, in other words, is carbon sequestration. We hear that term being used these days. That's what's happening there?
Right. So it's increasing the carbon input to the soil compared to a cereal crop, and that definitely increases the carbon sequestration. And the thing that surprised us when we looked at the numbers is that we can see that there's been a big increase in soil carbon input across Canada since about 2005 in particular. And then when we looked at it more in depth, that 70% of that increase was due simply to canola. So canola was dominating the whole carbon input for the whole country of Canada, and in that achieving quite large carbon sequestration, or at least what our estimates are that it's contributing to a huge carbon sequestration.
So 70% of all the national agricultural land, or what's the bottom number in that fraction?
Well, the 70% of the increase in carbon input. So
in farmland.
But from 2005, you can attribute it simply to canola because it's both increased in area, increased in yield, and then, as I said, because it has a much higher carbon input per unit of production, that when you put those two things together, it is dominating the increase in carbon input, and it's that increase in carbon input that really accomplishes the carbon sequestration.
Yeah. So when we think of canola, though, we think of a crop that has fairly little residue left, at least the next year. It breaks down fairly quickly on the surface. Where is that carbon sequestration or input into the soil happening?
Well, I think one thing about canola is a lot of the residue does pulverize during the harvest operation, or breaks down, as you say, very quickly, often mechanically quite quickly, and that actually helps, I think, getting into the soil. So fungi growing up, or even small bugs and things, are carrying it down and moving it down into the soil probably more effectively than a lot of cereal residues, and so that is how the carbon is getting into the soil.
And I guess the root system itself too it's got a big root compared to some other crops, including cereals.
Yeah, it has a very, very big. The roots are bigger, and they just have more biomass. Of course, that's obviously effectively in the soil, and then that is then even more effective for carbon sequestration, really, than the above ground. So it's just that's a big part of why it's cooler.
One of the interesting comments made here by Murray Hartman from Alberta Agriculture, noticing or observing how in agriculture for many years, including with the whole green revolution and semi-dwarf wheat, the focus has been on increasing the ratio of seed or food to biomass. This is kind of running counter to that, or kind of a benefit now where canola doesn't have that as good a ratio potentially as a semi-dwarf wheat or cereal crop, but now we're seeing an environmental benefit to that?
Yeah, it is interesting. That what you might was always looked at kind of as an inefficiency is actually an efficiency when your goal is to try to increase the amount of carbon, and that of course pulls CO2 out of the atmosphere, so that mitigates climate change. So something that's an important thing, and that has been identified as one of the biggest opportunities globally, is we need crops that can do that, and here Canada already has one, and here we're expanding its area as well. So we're achieving that. I want to mention then the other part of the cooler crop is that canola is much more reflective than a cereal. And most of that's just the flowering period. I mean, you only have to drive by a flowering canola field to know it's bright. and that actually has a very strong cooling effect. You wouldn't think about it, but again, when you start thinking about the millions of hectares, and suddenly you've got reflecting back
the whole greenhouse effect.
Yes, and that's really what the greenhouse effect is about what they call radiative forcing, and this is one way you're getting rid of that radiative forcing by reflecting the visible light right out, and so that's an important factor as well. And that, of course, unlike carbon sequestration, which doesn't continue forever, that sort of extra reflectiveness continues to cause cooling forever. So it's a very positive cooling effect in terms of if you want to mitigate climate change, or even if you just want to reduce those hot July days. It's going to have you can imagine it's going to have a major impact on that, and that's from a yield perspective. That's also very important because every crop actually can be damaged by high temperatures during flowering.
Yeah, and that, like you said, it's not a one-time event or one-time change. That's happening constantly.
Yes.
So was that reflectivity comparison, was that done on an annual basis, and if so, would that include snow catch? Canola could potentially have an advantage over some other crops in that area too?
Yeah, it was done on a year-round basis, and so I was looking at wheat fields versus canola fields from satellite imagery, sort of saying what's being reflected back. So it does capture all that, but it is a good point that the canola stubble, of course, does very good actually at retention of snow. So that of course is also a big cooling effect. And again, we can all relate to that. We know in the springtime, once the snow is gone, it starts warming up very quickly. The air temperatures, yeah.
All right. Well, thanks for taking the time and making the case, at least the argument for why canola is a cooler crop. Thanks.
Thanks.